All right, let's take a look at some trig story problems just to kind of get you used to thinking about this. So this first one is just going to ask you to find the length of a ladder. So you got some ladder is leaning against a wall. So the wall is over here. And what you know is that the ladder and the ground, right, this is the ground here, the ladder and the ground make a 50-degree angle. So it's that angle. And you know that the ladder's base is 12 feet from the wall. So you know that this distance is 12, the angle is 50 degrees, and they want you to find the length of the ladder. So you're going to use trig, and you're going to remember that this 12 is the adjacent side. This is the hypotenuse. Adjacent and hypotenuse are solved by using cosine. So cosine of 50 degrees equals 12 over L. This is a two-step algebra because the variable's in the denominator and we need it in the numerator, so we're going to be L cosine 50 equals 12, and then L equals 12 divided by cosine 50. And we bust up our calculator. We take 12 and divide by cosine 50. 18.7. 18.7, that's in feet. Okay, so that's the length of the ladder. If you were interested in how high the ladder was on the wall, well then you could use the Pythagorean theorem in those two things. If you wanted to know the ladder angle it makes with the wall or the vertical, well then that's just 40 degrees, right? That'd be easy at that point. Once you know that's 50, you know that's 40. Okay, so we got some kite. So you're kind of standing over here, flying this kite. Here's the string, and there's the kite, right? The kite and the string are going to make some angle. And let's say you know you released 100 feet of string, right? This here, that line is the string, and you're holding it. There's the kite. And you know you have 100 feet of string, and then you measure that the angle the kite makes is 25 degrees. So if you know those two things, can you actually figure out how high the kite is? Sure. This is the opposite side. This is the hypotenuse. You want the opposite. You have the hypotenuse. Well, that's sine. Sine of 25 is h over 100. In this case, this is just one-step algebra. H is already in the numerator where you want it, so it's just 100 sine 25 equals h. 100 sine of 25, and we get h equals, what, 42.3. And that's in feet. Okay? All right. Let's say you know the diagonal of a rectangle, and you know the diagonal makes a 35-degree angle with one of the sides. It doesn't really matter if you have the rectangle like this or you have the rectangle like this. Just go ahead and draw a rectangle, draw the diagonal, and then, you know, probably just based on visually that this is the smaller angle than this one, so I labeled that one 35. It doesn't matter which one you want to find, x or y. Find one of them and then find the other one, and then when you know x and y, then you can find the area and the perimeter. Okay, so let's do y. So if we want to do y, this is the adjacent, and this is the hypotenuse. That's going to make cosine. Cosine of 35 equals y over 20. This is just one-step algebra. All we have to do is multiply by 20. So we're going to take 20 times cosine of 35, and we get 16.4. Let's go ahead and use trig for the other one. I don't even feel like doing the Pythagorean theorem. Let's do sine of 35 is opposite over a hypotenuse. So then x just equals 20 sine 35 and 11.5. Okay, so area is just length times width. So the area of this guy, the area of a rectangle, is just going to be 16.4 times 11.5. 11.5 times 16.4. So we get 188.6. And let's say all these things were in inches. So that would be square inches. The perimeter is twice the length plus twice the width, right? The perimeter is the distance around. So you go 2 y's and 2 x's. So that's just 2 times 11.5 plus 2 times 16.4. 55.8, and that would just be in inches, right? That's just the distance. Okay, And then maybe one last one. Again, try not to make this video too long, and I can't go over every possible story. But say we got some ramp, we got some ramp that some wheelchair access something, and we want it to be a 50 to 20 ratio. So we want for every 50 inches horizontally, we want to be able to go up 20 inches, right? It's kind of like a slope. And I want to know what angle that would be. All right, well, if this is the angle, this side is opposite it, and this side is adjacent. So that's tangent. Tangent of the angle equals opposite over adjacent. And I remember, oh, okay, if I want to find an angle, all I have to do is inverse trig. So then theta is going to be inverse tangent of 20 over 50. So we'll bust that up. Second tangent, right, inverse trig of 20 over 50. And I have an angle of 21.8 degrees. Now, if I wanted to find more, if I wanted to find the length of the ramp, I could just do the Pythagorean theorem. If I wanted to find the other angle, I could just subtract that from 90 and so on. So you're going to have ladders and kites and diagonals and ramps and all sorts of, right triangles. And then you're going to have missing sides and missing angles. And you're going to use trig and inverse trig to solve for those things. I guess my only other point I want to make is you have to draw a picture. So you're not gonna be always given the picture. You're typically gonna be given the paragraph. Read the story, draw the picture, label everything put in a variable for what you want. Like if you want the ladder, go ahead and write an L, or just always use X or whatever. If you want to know the height of the kite, write in the H, write in the givens, decide what they are, opposite and hypotenuse, so that tells you to use sine, and then go to work. And remember, solving them, it's either one step, two step, or inverse trig. Here the variable was in the denominator, and it took 2 steps. Variable in the numerator, 1 step. Variable is the angle, inverse trig.